Hi everyone, welcome back to my channel. This is the second video of cloud computing. In this video, let us see machine reference model. Machine reference model. Virtualizing an execution environment at different levels of the computing stack requires a reference model that defines the interfaces between the levels of abstractions which hide implementation details. From these perspective, virtualization techniques actually replace one of the layers and intercept the calls that are directed toward it. Therefore, a clear separation between layers simplifies their implementation, which only requires the emulation of the interfaces and a proper interaction with the underlying layer. Modern computing systems can be expressed in terms of the reference model described in this figure. At the bottom layer, the model for the hardware is expressed in terms of the instruction set. Architecture, instruction set architecture, ISA, which defines the instruction set for the processor, register, memory, and interrupt management. ISA is the interface between the hardware and software, and it is important to the operating system developer and developers of applications that directly manage the underlying hardware. The application binary interface ABI separates the operating system layer from the applications and libraries which are managed by the OS. ABI covers details such as low-level data types, alignment, and call conventions, and defines a format for executable programs. System calls are defined at this level. This interface allows probability of applications and libraries across operating systems that implement the same ABI. The highest level of abstraction is represented by the Application Programming Interface API, which interfaces applications to libraries, and the underlying operating system. For any operation to be performed in the application level, API, and ISA are responsible for make it happen. The high level abstraction is converted into machine level instruction to perform the actual operation supported by the processor. The machine level resources such as processor registers and main capacities are used to perform the operation at the hardware level of the central processing unit, CPU. This layered approach simplifies the development and implementation of computing systems and simplifies the implementation of multitasking and the coexistence of multiple executing environments. In fact, such a model not only requires limited knowledge of the entire computing stack, but it also provides ways to implement a minimal security model for managing and accessing shared resources. For this purpose, the instruction set exposed by the hardware has been divided into different security classes that define who can operate with them. The first distinction can be made between privileged and non-privileged instruction. Non-privileged instruction are those instructions that can be used without interfering with other tasks because they do not access shared resources. This category contains, for example, all the floating, fixed point, and arithmetic instructions. Privileged instructions are those that are executed under specific instructions and are mostly used for sensitive operation which expose or modify the privileged state. For instance, behavior sensitive instructions are those that operate on the input output, whereas control sensitive instructions alter the state of the CPU registers. Some types of architecture features more than one class of privileged instruction and implement a finer control of how these instructions can be accessed. For instance, a possible implementation features a hierarchy of privileges in the form of ring-based security, ring 0, ring 1, and ring 2, and ring 3. Ring 0 is the ring 0 is the most privileged level and ring 3 in the least privileged level. Ring 0 is used by the kernel of the OS. Ring 1 and 2 are used by the OS level services. And ring 3 is used by the user. Recent systems support only two levels with ring 0 for superior supervisor mode and ring 3 for user mode. All the current systems support at least two different execution modes, supervisor mode and user mode. The first mode denotes an execution in which all the instructions can be executed without any restriction. This mode, also called master mode or kernel mode, and is generally used by the operating system to perform sensitive operation on hardware level resources. In user mode, there are restrictions to control the machine level resources. If code running in user mode invokes the privileged instructions, hardware interrupts occur and trap the potentially harmful execution of the instruction. Despite this, there might be some instructions that can be invoked as privileged instruction under some conditions and as non-privileged instruction under other conditions. The distinction between user and supervisor mode also used to understand the role of the hypervisor and why it is called that. Conceptually, the hypervisor runs above the supervisor mode, and from here, the prefix hyper is used. In reality, hypervisor are run in supervisor mode, and the division between privileged and non-privileged instruction has posed challenges in designing virtual machine managers. It is expected that all the sensitive instructions will be executed in privileged mode, which requires supervisor mode in order to avoid traps. Without this assumption, it is impossible to fully emulate and manage the status of the CPU for guest operating system. Unfortunately, this is not true for the original ISA, which allows 17 sensitive instructions to be called in user mode. This prevents multiple operating systems managed by a single hypervisor to be isolated from each other. Since they are able to access the privileged state of the processor and change it, more recent implementation of ISA have solved this problem by redesigning such instruction as privileged one. By keeping in his mind reference model, it is possible to explore and better understand the various techniques utilized to virtualize execution environments and the relationship to the other components of the system. Thank you.